Hi, this is Sir Romy again. We are now on the special product number 5. What you will learn today? Multiplying a binomial and a trinomial of the form a plus or minus b times a squared minus or plus ab plus b squared. Okay, first I will give you an inspirational message. If you can't be kind, be quiet. Again, if you can't be kind, be quiet. Okay, so we are now on special product number 5, the last special product. We will be taking the product of a binomial and a trinomial of a special form. So, in order to get the product of a binomial and a trinomial, you have to check the characteristics of every given factors. Okay, what are those factors? The factors in multiplying a binomial and a trinomial of the form a plus or minus b times a squared minus or plus ab plus b squared have the following characteristics. The first term of the trinomial is the square of the first term of the binomial. Next, the second term of the trinomial is the additive inverse of the product of the first and second terms of the binomial. And the third term of the trinomial is the square of the second term of the binomial. Okay, so we will have some samples. But first, I think we have to derive the pattern. A plus b times a squared minus ab plus b squared. Okay, the first term of the trinomial is the square of the first term of the binomial. So, is this the square of the first term of the binomial? Yes, check. Next, the second term of the trinomial is the additive inverse of the product of the first and second terms of the binomial. So you have to multiply the first term and the second term of the binomial and see to it that the sign will be opposite to the product given on the second term. So a times b is positive ab. Is it the opposite of negative ab? Yes, check. Next, the third term of the trinomial is the square of the second term of the binomial. Okay, the third term of the trinomial is the square of the second term of the binomial. Is this the square of the second term? Yes. So, it must follow these characteristics. Okay? First term must be the square of this. Last term must be the square of this. And the middle term is the opposite of the product of the first term and the second term. The product of a times b is positive ab. Is it opposite to negative ab? Yes. Okay, now we will derive the same thing. We have to use the distributive property. A times what? A times the whole set, then b times the whole set. So, this will become what? A times a squared plus a times negative ab, second term is negative, plus a times b squared. Okay, first term multiplied to the whole set, then b times a squared plus b times negative ab plus b times b squared. Okay, simplify. This will become what? A times a squared. This will become a cubed. 1 plus 2 is 3. Positive times negative will become negative. A times a is a squared b. Next, a times b squared is ab squared Next, plus a squared b, because a comes first, then b. Then, negative a b squared. Positive times negative is negative. A times, this will become a. B times b is b squared. Plus b cubed. Are there like terms? Yes. These two are like terms. No. These two are like terms. And these two are like terms. Why? Because they have the same variable, same exponent. Same variable, same exponent. Okay, so these two are, and these two are like terms. Okay, so negative 1a squared b plus 1a squared b. Negative 1 plus 1 will become 0. So this will become 0. Positive 1ab squared, negative 1ab squared, positive 1 minus 1, this will become 0. So what will remain is a cubed plus b cubed. So this will be your special pattern. So why is this called a special product? Why is this called a special product? Because whenever you encounter these special characteristics of multiplying a binomial and a trinomial, you will acquire this pattern, a cubed plus b cubed. Okay, you will not undergo with this process anymore. So just simplify, just substitute all the terms. Okay, so we have a pattern now. Okay, how about if the other way around? A minus b times a squared plus ab plus b squared. Okay, the first term must be the square of the first term here. Check. The last term must be the square of the last term here. So negative b times negative b will become b squared. Check. The product of these two terms, a times negative b will become negative ab, is the opposite of this term. Yes, negative ab is the opposite of positive ab. So check. So this is also a special product. Now, we will derive the pattern. Simplify this. The first term multiplied to the whole set, and the second term multiplied to the whole set. So this will become what? A times the first term plus a times the second term plus a to the third term minus b, we're now the second term, times the first term minus b times the second term minus b times the third term. Now simplify. This will become what? A times a squared, a cubed. 1 times 1 plus 2 is 3. Then a times a will become a squared b. Then a b squared. Negative times positive, negative a squared b. A comes first, then b. Then negative times positive, negative a b squared. B times b is b squared. Negative times positive is negative b cubed. Now, are there like terms? Yes, these two are like terms. Same variable, same exponent. These two are like terms. Same variable, same exponents. Now, 1a squared b minus 1a squared b. 1 minus 1, this will become 0. 1ab squared minus 1ab squared. 1 minus 1 will also become 0. So what will remain is a cubed minus b cubed. So this will be your second pattern. Again, why is this called a special product? Because whenever you encountered this product of a binomial and trinomial of a special form, this will be your pattern. You will not undergo on this process anymore. So you have to substitute the terms on the pattern. Okay, what have you noticed? What have you noticed? Okay, if this is positive, this is negative, positive answer, positive product. If this is negative, this is positive, negative on the product. Okay, don't be confused. Positive binomial, positive product. Negative on the binomial, negative on the product. Okay, let's take an example. Let's take, no, we will not take an example yet. We have to verify if the factors follow the special pattern. If they do, find its product. Okay, letter A. M plus 2, m squared plus 2m plus 4. Okay, are these factors considered a special product of a binomial and a trinomial of the special form? Okay, let's check. Is this the square of the first term? Check. Is this the square of the second term? Check. Is this the opposite of the product of m times 2? 2 times m is 2m. Are they opposite? No. So this is not factors of special product. Okay, letter B. 5y minus 2 times 25y squared plus 10y plus 4. Is this the square of the first term? 5 times 5, 25, y times y squared, check. Is this the square of the second term? Negative 2 times negative 2 is positive 4, check. Is this the opposite of the product of the two terms here? 2 times 5, 10, negative, positive, negative, negative 10y. Is negative 10y opposite of 10y? Yes. So this is check. And your answer is what? Your answer is you have to cube. You have to cube the first term. Then since this is negative, you have to follow this pattern. This will become what? Negative. Your b cube. Your b cube is 2. Okay, remember, you will not place the negative sign here on your pattern because this is already carried over. Okay, you might be confused. You will be only copying the absolute value, 2. Do not prefix the negative because this is already carried over on your pattern. So this will become what? 5 cube y cube minus 2 cube. So 5 times 5 times 5, 125 y cube minus 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So this will be your final answer. Okay, let's check another one. Letter C. Let's take 8p minus 5r times 64p squared plus 40pr plus 25r squared. Okay. Let us remove this now. So your answer here is 125 y cubed minus 8. Now, let's check. Is this the square of the first term? 8 times 8 is 64. P times P squared. P squared. Check. Is this the square of the second term? Negative 5 times negative 5 is 25. R times R is R squared. Check. Is this the opposite of the product of the binomial? The product of the first and second term. 8 times 5 is 40. Negative times positive is negative. Negative 40 PR. Is it the opposite of positive PR? Check. So, our answer will be 8p cubed. Since this is negative, we have to use the negative pattern. 5r cubed. Now, what is your answer? 8 times 8 times 8. 8 times 8, 64. 64 times 8, 512. P cubed. Okay, remember, have to distribute. Minus 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. R cubed. So this will be your final answer. Okay. Next, we still have a space. Okay, let's check. Letter D. 5t minus 1 times 25t plus 5t squared plus 1. Okay, let's check. Is this the square of the first term? 5 times 5 is 25. T times t is... No. T times t must be t squared. So, on the first glance, this is not a factor. Not factors of special product number 5. So, okay, so this is not a special product, this is not a special product, this is a special product. Okay, so just follow the rule and it would be easy for you to substitute to the pattern. Okay, so that's it.